May 1940, somewhere in northern France, a German Panzer III commander spots what looks like a children's playground obstacle blocking the road ahead. 4 railway rails, each weighing 300 pounds, welded into an X shape and planted in the ground like a giant metal jack from a child's game. His orders are to push through to the Channel coast. The blitzkrieg doctrine depends on speed. Concrete barriers can be demolished with enough time and explosives, but time is what the British are buying. He signals his driver forward. The 22-ton tank accelerates. The collision sounds like a church bell being struck with a sledgehammer. The front rail punches the lower hull. The tank lurches sideways. The driver guns the engine. Tracks spin uselessly against steel. The entire vehicle is now suspended, belly exposed. Tracks off the ground, engine screaming. Behind him, the entire column stops. This is the Hedgehog anti-tank obstacle. A weapon so simple it looks medieval, so effective the British Army ordered 500,000 of them before France even fell. And what makes this story remarkable is not that it worked, but that Germany never built anything comparable until they were losing the war. How did a device with no moving parts, no explosives, and no electronics become one of the most cost-effective anti-tank weapons ever deployed? To understand why Britain built 500,000 metal jacks, you need to understand what was coming. By June 1940, the Wehrmacht had demonstrated that armored divisions could cover 50 miles in a single day across decent roads. Panzer IIs, Panzer IIIs, and the heavier Panzer IVs had punched through the Ardennes, bypassed the Maginot Line, and reached the Channel in less than 2 weeks. The speed wasn't just tactical, it was existential. If German armor could move freely across southern England the way it had moved across France, the war was over. Churchill's government faced a nightmare scenario. Roughly 3,000 miles of British coastline potentially vulnerable to invasion. Perhaps 200,000 German troops could land in the first wave if Operation Sea Lion proceeded. The British Army had left most of its heavy equipment in France during the Dunkirk evacuation. According to War Office records from June 1940, the entire British Army possessed fewer than 100 operational tanks on home soil and perhaps 420 effective anti-tank guns to defend an entire island. The obvious solution was concrete. Anti-tank cubes, also called dragon's teeth, had been used in the Siegfried Line and the Maginot Line. Pyramid-shaped blocks of reinforced concrete arranged in rows could theoretically stop or channel armor. But concrete requires time, materials, and transportation. Each dragon's tooth needed roughly 1 cubic yard of concrete, meaning approximately 3,000 pounds of material per obstacle. Britain in mid-1940 had neither the cement production capacity nor the transportation infrastructure to pour hundreds of thousands of tons of concrete across southern England while also building airfields, dumbly slimmer, repairing bombed infrastructure, and constructing coastal defenses. Then someone at the Directorate of Fortifications and Works remembered railway scrap. Britain's railway system had been continuously upgraded since the Victorian era. Older lines used lighter rail sections. Modernization programs had replaced them with heavier standards. By 1940, Britain had accumulated vast stockpiles of obsolete railway reel, each section weighing between 75 and 95 pounds per yard. This steel was already paid for, already distributed across the country in railway sidings and scrapyards, and critically, already shaped into long, rigid beams ideal for structural use. The Hedgehog design emerged from this constraint. Take 4 sections of rail, each approximately 5 feet long. Weld them together at the center point so they radiate outward in an X pattern when viewed from any angle. Anchor the base into the ground or a concrete footing. The result weighs roughly 1,200 pounds, stands about 3 feet high, and presents a tank with an impossible geometric problem. Here's why it worked better than concrete. A tank crossing a concrete dragon's tooth can use its weight and traction to climb over if the obstacle is low enough, or push through if the obstacle is poorly anchored. The Hedgehog offered no flat surface to climb. Its 4 rails pointed upward and outward at angles specifically calculated to catch the underside of a tank's hull. When a Panzer III, weighing approximately 22 tons, hit a Hedgehog at speed, the pointed rail tips concentrated that entire impact force into a few square inches of contact. The rail didn't need to stop the tank through mass. It needed to lift the front of the tank just high enough that the tracks lost contact with the ground. Once a tank was suspended on a Hedgehog, its own weight became the trap. Tracks spinning in the air generated no forward momentum. Backing up risked impaling the vehicle further. Engineers would need to arrive with cutting equipment or explosives, and while they worked, the tank was a stationary target. The British called them hedgehogs because of their spiky appearance, though the official designation was Obstacle Anti-Tank Hedgehog Mark I. Production started in July 1940. The design required no specialized manufacturing. Any workshop with welding equipment and a supply of scrap rail could produce them. According to surviving Ministry of Supply records, production was decentralized across hundreds of small engineering firms, railway workshops, and even agricultural equipment manufacturers. The specifications were simple enough that quality control was almost unnecessary. As long as the rails were welded securely and the angles were approximately correct, the obstacle would function. By September 1940, hedgehogs were being deployed across southern England in numbers that would have been impossible with concrete. They appeared at crossroads, blocking potential tank approaches. They lined beaches where invasion was expected, often placed below the high tide line so they would be invisible to landing craft until the last moment. Entire fields were studded with them, turning flat farmland into impassable terrain for armor. Some crossroads received 20 or 30 hedgehogs arranged in overlapping rows. A single panzer company attempting to push through would face a gauntlet where every vehicle risked becoming stuck, blocking the vehicles behind it. But the real genius was the multiplication effect. Every hedgehog forced German planners to account for it. Tank commanders couldn't simply drive cross-country anymore. They needed engineers forward to clear obstacles. Engineers needed infantry protection. Infantry needed time to deploy. Time meant exposure to British anti-tank guns, artillery, and air attack. The hedgehog didn't need to destroy tanks. It needed to slow them down long enough for other weapons to engage. A Panzer IV stuck on a hedgehog for 5 minutes was worth more to British defenders than a Panzer III destroyed immediately. Because every minute that tank was immobilized, it blocked the advance of every vehicle behind it. The British tested hedgehogs extensively at the Fighting Vehicles Proving Establishment in Surrey. Captured French tanks and obsolete British models were driven at various speeds into hedgehog arrays. The results were documented in War Office reports now held at the National Archives. A tank hitting a hedgehog at 15 miles per hour would typically become immobilized within seconds. The impact bent the front rail but rarely broke the welds. The tank's momentum carried it forward, driving the rail point upward into the hull. In tests, approximately 70% of impacts resulted in the tank becoming completely stuck, requiring external assistance to free. The remaining 30% involved glancing blows where the tank deflected sideways but still suffered track damage or hull punctures. Interestingly, the hedgehog's effectiveness increased with the weight of the attacking vehicle. Heavier tanks like the Panzer IV, at 25 tons, generated more impact force, which drove the rail points deeper into the hull. This was the opposite of concrete obstacles, where heavier tanks could often bull through barriers that stopped lighter vehicles. The hedgehog turned the tank's own mass against it. German military intelligence became aware of the hedgehog obstacle system by late 1940 through aerial reconnaissance photographs. Luftwaffe reconnaissance flights over southern England clearly showed the distinctive X-shaped obstacles dotting the landscape. Yet Germany never developed a comparable portable anti-tank obstacle during the critical years when they held the strategic initiative. Why? The answer reveals something about German military doctrine. The Wehrmacht's operational philosophy from 1939 to 1942 centered on offensive maneuver. Blitzkrieg tactics emphasized breakthrough, exploitation, and encirclement. Defensive obstacles were considered necessary for static defensive lines like the Atlantic Wall, but the primary defensive tool was counterattack, not passive barriers. Germany built elaborate concrete fortifications, minefields, and bunker systems. But the concept of a cheap, portable, mass-produced obstacle that could be deployed rapidly across vast areas simply wasn't part of German planning until the strategic situation reversed. When Germany finally did adopt a similar concept, it was 1944, and they were losing. The Panzer Speer, a welded steel beam obstacle similar in concept to the British hedgehog, appeared in German defensive positions during the fighting in Normandy, and later during the defense of Germany itself. By then, Germany was fighting a defensive war, trying to slow American, British, and Soviet advances. Some sources suggest these were directly inspired by captured British hedgehogs encountered in North Africa and Italy. What's documented is that these obstacles appeared in significant numbers only after Germany had lost the strategic initiative. Britain deployed 500,000 hedgehogs in 1940 when they faced invasion and lacked resources for elaborate defenses. Germany deployed similar obstacles in 1944 when they faced invasion and lacked resources for elaborate defenses. The difference was Britain thought defensively when they were weak and needed to buy time. Germany thought offensively until they had no choice. British hedgehogs remained in place throughout the war. As the invasion threat receded after 1941, many were removed from roads and relocated to less obtrusive positions. Some were deployed overseas. British forces used hedgehogs in North Africa, though the sandy terrain required deeper footings or concrete bases. They appeared in Italy, where they blocked mountain passes and defended bridges. After D-Day, British engineers deployed hedgehogs on the Normandy beachhead to protect vulnerable sectors against German counterattack. The cost comparison between hedgehogs and alternative defenses is striking. A single concrete dragon's tooth required approximately £2 to £3 in materials and labour at 1940 prices according to contemporary engineering estimates. A hedgehog, using scrap rail and basic welding, cost roughly 10 shillings or £0.50. For the same investment, Britain could deploy 6 hedgehogs instead of one concrete obstacle. The hedgehog could be moved if needed. Concrete was permanent. If tactical requirements changed, hedgehogs could be lifted by crane, transported, and replanted. The production numbers tell the story. By the end of 1940, Britain had produced approximately 500,000 hedgehogs. Concrete dragon's teeth production in the same period numbered in the tens of thousands. The manufacturing capacity required for 500,000 concrete obstacles would have consumed Britain's entire cement production for months. The hedgehog allowed Britain to defend in depth without sacrificing resources needed for airfields, ship construction, and bomb damage repair. One detail that often goes unremarked is what happened to these hedgehogs after the war. Tens of thousands were simply left in place, gradually rusting into the landscape. Others were collected and recycled during post-war scrap drives. A few remain today, preserved at military museums or standing forgotten in overgrown fields. The Imperial War Museum in London displays an original hedgehog. If you see one in person, the craftsmanship is rougher than you might expect. Welds are functional, but not pretty. The rails show signs of their previous life in Britain's railway system, sometimes with original markings still visible. The strategic impact of the hedgehog extended beyond its immediate defensive function. Operation Sea Lion, the planned German invasion of Britain, was postponed indefinitely in September 1940 and ultimately cancelled. Multiple factors contributed, primarily Germany's failure to achieve air superiority during the Battle of Britain. But German planning documents from 1940 show that Wehrmacht planners were deeply concerned about the logistical challenges of crossing the Channel and sustaining an advance inland against prepared defenses. Every hedgehog, every anti-tank ditch, every defended position meant slower progress. The cumulative effect of Britain's defensive preparations, of which the hedgehog was a visible symbol, convinced German planners that even if they landed successfully, the subsequent inland campaign would be extraordinarily costly. That makes the hedgehog's true value impossible to quantify. How do you measure the impact of a weapon that worked by existing? We know from German intelligence assessments that the density and extent of British defensive preparations were cited as factors against invasion. We know that no German tank ever actually hit a hedgehog in combat on British soil because the invasion never came. The hedgehog succeeded without firing a shot, which is the highest form of strategic victory. 4 pieces of scrap railway welded together in an X. No electronics, no explosives, no moving parts. Built in thousands of workshops by workers who would never see combat. Planted in fields and beaches across an island, bracing for invasion. Germany spent fortunes building tanks. Britain spent almost nothing stopping them. Not because British engineering was more sophisticated, but because British strategic thinking in 1940 prioritized survival over prestige. The hedgehog wasn't elegant. It wasn't innovative in any technological sense. It was simply the most effective way to turn scrap metal into time, and time was the one resource Britain desperately needed. That's not luck. That's operational pragmatism under existential pressure.